Hey, Mike here. So my channel is pretty much about refrigeration. I've been working on a little refrigerator for the last couple of months. It's coming along pretty well. I started all this refrigeration nonsense a couple of years ago because, well, I was interested in it, and I've been interested in theory and antique refrigerators for some time now. So I looked around on YouTube like one does, and I couldn't really find much. So I thought, if I'm going to get into this, I'm going to share some of what I do and I like. And because I can't find a lot of people that do this kind of stuff, it's allowed me to connect with a few folks out there that are interested in these kinds of things. There's plenty of good videos out there to watch about HVAC, like commercial, like guys that do this stuff every day for a living, working on big industrial stuff, residential AC, heat pumps, that kind of stuff. And there's a lot of really valuable information in there. I mean, these guys have years of experience. As far as like kind of DIY, do it yourself at home, not using off the shelf parts and kind of hacking things together, it's really lacking. So, that's what I try to do with my channel. There's a couple of other channels out there. Sean Dobby, his actual name is Sean Dabby, I believe, but it's spelled D-O-B-B-I-E. I'm subscribed to it, so if you check out my page, you can get a link to his page there. He's over in the UK, and he does a lot of cool stuff with blends, isobutane and propane blends, and building his own little heat pumps and stuff. He's got a little shack, kind of like mine, congested and messy, but he's very productive over there, so check him out. So I've been getting a lot of emails in the last couple of months, mostly over this summer, about like little DC compressors and building an air conditioner. So I worked with this little DC compressor last year. It's a brushless DC compressor, and I plan on using it here again in the future. It's just right now I don't really have a need for it. I just use the AC one that I dug out of an old refrigerator. The thing with an AC, a direct current air conditioner, people make the point all the time that when you need cooling is when the sun's beating down, so that's when you usually have the extra electricity supplied from your photovoltaics. Very logical, makes a lot of sense, but just jumping into it and building a DC air conditioner, it's not necessarily that simple. But if you want to do it, by all means, pursue it and video it and put it on YouTube. I'd love to see what you find. So I'm kind of making this video specifically for an email I got the other day. Someone asked a lot of questions. Some of them were basic questions, but they're all very, very good questions. So I thought the best way, rather than spending hours trying to write a lengthy email, is to make a quick video and just kind of show some of the tools that I use and some of the things you might need to get into this. So the first thing that you need is a good book. You got to do some reading. You can't just do YouTube and stuff. There's plenty of good illustrations and animations and stuff like on YouTube that'll explain how a capillary tube works and how a refrigerator works and things like that. But you can't beat a good book. So I would recommend getting a nice thick vocational book, HVAC refrigeration. Nice big thick hardback book. Get one from the 80s, early 90s or something. Seems like those ones were a little better. There's a good one, I don't know the specific name of it, but it's kind of green. It was a very popular book. I like that one better than almost any of the other ones. And in a book like that, it's going to start off with basic theory, and it's going to get into air conditioning, refrigeration, and explain all the components and the tools, refrigerants and how they work, brazing, working with copper, flaring, vacuuming a system down, recovering refrigerant, on and on and on. That's going to get you familiar with pretty much all the things that I'm going to talk about here in this video. But as far as the stuff that I use, and just kind of give you a overview, one of the first things that you're going to need is, after the book, is a set of gauges. This is just a pretty basic set of gauges, a little bit better than the ones you'd buy at Harbor Freight, and that might be all you need. This set here has four valves rather than just three, so I actually have also a vacuum valve there as well, along with a 3/8 vacuum hose. But don't overdo it with the gauges. You don't have to buy the yellow jacket stuff. Something else that you're going to need is probably a vacuum pump. If you're planning on doing anything and you don't want it to crap out on you anytime soon, you probably should evacuate it, and get a nitrogen tank with a regulator and purge it and all that good stuff. If you're looking to just kind of fool around and you decide that you want to work with propane, You can get away with just purging propane through a system. You're not going to get all the water vapor and stuff like that out of it. You're always going to have some contaminants, but there are ways to go about that without a vacuum pump. That's the way they used to do it back in the old days. And there's not really an environmental concern with venting propane. Don't do it in large quantities, and don't turn a bottle upside down and freeze your fingers off and all that kind of stuff. But there are ways to get a lot of the air and the non-condensables out without a vacuum pump. But I would definitely recommend considering one if you're going to get into this, as a long-term hobby. This one's only about 1.5 CFM. It's one of the smaller ones that you can get. I wouldn't go any bigger than that for a small project. It's really unnecessary. You're going to spend more money. It's going to make a lot more noise and use more electricity and all that good stuff. Get yourself some vacuum pump oil too. You're going to have to join copper together. I work with mostly 1/4 inch. Some 3/8, some 3/16, and then of course the capillary tubing. I've been told that MAP gas will help you braze, and I haven't had that experience. It's hard to get the copper hot enough to braze properly with it. In my opinion, you need an oxygen torch of some sort. You can buy one at Home Depot like this, which I did some time ago. I think it was about a little over a year and a half ago. They come with a tank of MAP gas and a tank of oxygen. The problem is you're going to run through the oxygen rather rapidly. So what I actually did was I used that torch and I modified a regulator to work with a full tank of oxygen, and then I used a propane tank for the fuel source. Now I have this is actually a cutting torch with a brazing tip on it. It's a good way to go. This gets plenty hot for anything that I need to do with it, and it will get hot enough that it'll melt the copper. So you got to be careful. So if you're going to get into brazing, you got to get a lot of practice. Don't just jump right in and start trying to braze your project together. This is a brazing rod. It's 15% silver. Most of the rest, I believe, is copper. Stuff's expensive. You can get it at a welding supply, refrigeration supply. Get online, of course, but it'll go a long ways for small projects. So another way to join copper is you can solder it. I don't have a lot of experience doing that. It was a very common method for like lower pressure systems generations ago, I believe, but this is 95.5 tin antimony. This isn't actually, I didn't buy this for joining copper. I bought this for stainless steel, and it works just fine for that. You can get silver solder at Home Depot, get online, places like that. And if you go that route, which, if I were to do this all over again, I would probably consider it, because you should be able to get away with just a propane torch or a MAP torch. These are handy things to have here. An automatic torch. In which case you're probably going to end up having to use some kind of a flux. But it's something to consider if you're not looking to do a huge investment right away, is to go with a solder. But it should be a silver containing solder. Do your research on that before you jump into it, and pressure test everything if you can under nitrogen pressure. Use an inert gas. Another way to join copper together is flares. So that's a 1/4 inch flare nut that slides onto a piece of copper. Where do we have one here? So there's a example right there. Then there's a union. You read your book, you're going to learn all about that. Here's a flaring kit. That was purchased at Home Depot. It's done every one of my projects. It works just fine. Maybe one day I'll buy a better one. But I can also swage with it too. Swage, whatever. Where you open up a piece of copper tubing so you can braze another one inside of it the same diameter. And then of course there's all kinds of other fittings and stuff in here. You read your book, you're going to learn about a lot of this stuff. But flares are a nice way to be able to put a system together and have all these points where you can break it back apart whenever you want to change something. I've changed this particular setup dozens and dozens of times, and it's much more convenient to be able to break a flare than it is to have to cut into or unbraze a copper line. Just a lot less messy, but they can be leaky, so don't expect to be able to flare up your entire project and then expect it to work for years on end without issue, because it probably will leak. Not to say that some flares properly done will have a problem. It's just that if you take one apart several times like I do, you're eventually going to have problems with it, and they're really not to be trusted. You should braze or solder everything. So what else? You'll learn about Schrader valves. It's like a bike valve or a tire pressure valve, probably about the same guts, and that's so you see one in there. Now this is a special thing here. This is actually designed to pierce into a copper line, a 1/4-inch copper line, after this assembly has been brazed on, and then you push this thing in, thread the nut on, and it pierces through. That gives you a little access port. They're kind of handy to have once in a while. More of a permanent solution than using a bullet piercing valve. These are handy if you're working on an existing refrigerator, dehumidifier, air conditioner, because you can recover the refrigerant. You can purge it with some nitrogen while maybe you're doing some brazing work, but eventually you need to put a permanent stub of some sort on there. Something else you're going to work with if you're going to do an air conditioner is capillary tubing. You asked about what capillary tubing is. It's a metering device. It's a fixed bore length of copper tubing, just very, very thin with a very, very small hole. This one has, this is 26, so this is 0.026 inches inside diameter. Very, very, very small. 16 feet came in this thing. I have 10 feet running in this system right here. But if you look, when you buy this stuff, and you can find these charts online, so before you even buy one, because I have some 36, some 42, and different lengths over here, or different bores, you can find charts online. This stuff is made by JB Industries. I know for a fact that there's a PDF online that contains some recommended bores and lengths for whatever your application is. So, for instance, air conditioning. And depending on the compressor size and that kind of stuff, and that'll give you an idea what you want to get. A good vocational book should probably describe how to cut capillary tubing. These are cutters. I actually own a pair of these cutters. They do a nice job. Do not use snips or anything that'll crush the copper tubing, because you won't be very happy with the results. You can also, there's a scoring method where you can actually score with a file edge where you want to cut it, and then bend it till it snaps off, and then tap the copper and get any kind of filings out. So, something I would recommend if you're going to mess around with capillary tubing, you're probably not going to find the right length of it right off the bat. Rarely does anybody find that to be the case. So you're going to end up cutting it long, and then testing it, and then cutting it back until you find a length that works well. I would recommend you flare that kind of stuff up. So you can see what I have here. This piece of capillary tubing has a flare joint, 1/4-inch flare joint on both ends. Now for this application, this is just to have a pressure gauge remotely mounted. But this could work easily just as well. Here's two of those right there, where they're remotely mounted. But here's the actual capillary tube for this refrigerator here, and you can see that I have it brazed into a piece of pinched 1/4-inch tubing after I flared it. And if you do that on both ends, that allows you, once you've depressurized the system, to unhook it at one end or both ends, and then unbraze this, cut it off to whatever length you need, and then rebraze it, so you don't have to do it in the system. And then you can just put the component back in, or you could just pull the whole assembly out, set it aside, and maybe you have another one made up with a different bore or length of capillary tubing that you have these flared up on the end. So that can be convenient and a little easier and less frustrating than constantly rebrazing it while it's in some awkward position. So I talked about some of those fittings. I don't really know what else to tell you except for a whole lot of everything. It's a fun hobby. I really enjoy it. I wish I could get other people as interested in it as I am. There's a lot of good knowledge out there. I find that a lot of HVAC, guys that do that, commercial work or residential work they're usually not very interested in it. I'm kind of dorky and nerdy about it. Get some old books. Old books, like pre-1960, good old books, 1920s, 30s, 40s. You find some great information in there that'll really give you a good common sense understanding of refrigeration. Specifically about the direct current air conditioner. I think I get this question a lot, and I think people underestimate the size of compressor that you would need for even a small, 6,000 BTU per hour air conditioner. I don't know the numbers off the top of my head, but let's say, a small, 6,000 is probably one of the smaller ones you can get. Maybe you can get like a 4,400 or something like that. But let's just go with the 6,000 BTU per hour air conditioner. We're talking what 8-10 amps or something like that, So, not including the fan, you got to consider that if you're going with like a 12 volt unit and a 12 volt compressor to replace essentially, a 120 volt compressor, say if you were just going to modify an existing like window AC unit, you got to take whatever amperage that original unit used and pretty much multiply it times 10. That's what your DC compressor is going to be. Now this thing is about 115 watt is what it's rated at. You're going to need a compressor that's at least 5 times this size, in terms of wattage. I wish I prepared for this a little bit better to, give you a better idea of what size you really need, but I think one of the easiest things to do is to do that, to just modify an existing window unit, especially if you don't have a lot of experience building this stuff, because you're going to get really frustrated if you select your compressor and then try to build everything around that compressor. Let some engineering schmuck do the work for you. Take an existing window AC unit and then try to find a compressor that will replace that. That's essentially equivalent to that in wattage. Now, if you change the refrigerant, you're going to end up having to change the capillary tube, which you probably would have to do anyway. But in that way, you don't have to. It won't be as frustrating. Let's put it that way. If you're going to go all DC, you're also going to have to change the fan motor out as well. You might decide that you want to go with a large brushless DC like computer fan type thing. It's definitely an option, but you also have to consider how much airflow the original unit was designed for. If you go for a smaller compressor, you might have to reduce the airflow, and in some cases you might have to increase the airflow. So there's a lot of factors involved in it. I would love to see a good video on this, or someone's attempt at this, even if it's you're frustrated and you're having trouble with it. I'd love to help, but to get into it and try to explain to you exactly how to go about it, it's going to be tough. But if you have more questions, by all means, email me. Anybody can email me or comment on the video or whatever it is, or make a video of your own. But here in the near future, I'm going to be doing a lot more work with the fridge here. I'm going to do an overhaul here in the next couple of months, completely redesign it, probably get into put a new cabinet, might make my own wooden cabinet here in the near future. I'm going to be getting back into ejectors in the next couple of months. Really starting to get a better understanding of some of the data that I'm collecting. And if you decide that you want to do this kind of stuff, I can definitely recommend ways to build. I have a series of videos on thermocouples and data collection and stuff like that. It gets a lot more fun once you get into the nitty gritty stuff. But just getting something that actually works is a little titillating. It's always a lot of fun to move some heat around. So like I said, any questions, throw me a comment, pitch me an email. But hope that helps a little bit. So, bye. One more thing I forgot. There was another question that was asked about charging. With refrigerants, you typically don't dump the refrigerant in because it's if you get this liquid out of this tank, it's going to come out quite cold because this stuff will boil at about negative 44 degrees Fahrenheit at atmospheric pressure. Most of your refrigerants are going to boil at a low temperature. So you don't dump it in. You charge it as a gas. Now, if you read anything about refrigeration, you learn some of the basics. You'll learn about charging refrigerant, but to hook up a propane tank like this, I just use one of these adapters. You can get them in like a farm supply store, good hardware store. This one goes from what's called a disposable propane tank, or disposable 1 pound tank, to a 1/4 inch national pipe thread, and then you'll have to adapt it to a flare. If you can find one that just goes straight to a flare, that's awesome. Let me know where you found it. But this one I just had to assemble with a few pieces, a few parts, and then I go to a 1/4 inch flare, and then I'm able to put that right to my charge line for my compound gauges. You can charge as a liquid. When you charge as a liquid, you turn the tank upside down so the liquid is sitting in the bottom. But for any kind of a small system, you're probably going to be charging as a vapor into the low side. So there are cases where you might want to charge as a liquid, but you have to be really careful if you're admitting that into the low side. You have to just meter it really slowly, or run it through a length of copper tubing so it flashes off. There are good reasons why you might want to do that as a liquid for propane, just because whenever you're doing it as a liquid, you have all the heaviest substances there in the bottom of the tank, and some of the non-condensables, some of the lighter gases are probably going to remain in more of a vapor state. But I generally just charge as a vapor and deal with any water content with a filter dryer. But in the future, if I ever decide that I want to, design a system that's going to last a lot longer, and I'm not going to be constantly going through propane, I would just get refrigerant grade R290. So that's something that you might need if you're going to end up doing propane. Otherwise, if you get like R134A or something like that, it's going to have a 1/4 inch flare fitting on the top. Thanks.